a mystery interstellar object that was spotted by astronomers last week. It could be the oldest comet ever seen. It's only the third time that we've actually detected an object that has come from beyond our solar system.
Imagine an object older than our sun, speeding through our solar system at 130,000 miles per hour, defying the very laws of physics. This isn't science fiction, it's 3I Atlas, a mysterious interstellar comet that is rewriting everything we thought we knew about space. Discovered only recently, its bizarre behavior has left NASA's top scientists scratching their heads. Could this be just a comet, or is there something far stranger lurking in its cosmic dust?
And a mysterious visitor is on its way to Earth, moving closer, 137,000 miles per hour. Is it an alien ship, a comet? Scientists and researchers are left puzzled. To unpack the mystery behind 3I Atlas.
When 3I Atlas was first spotted, it seemed like a normal comet at first glance. It was in the right place, moving in the right direction. But as astronomers observed its movements more closely, they realized that this object was far from typical. This was not your run-of-the-mill space rock, but an object from beyond our solar system, traveling at a speed and trajectory that made it stand out from everything we've seen in our history of space exploration. Before we get into the specifics of 3I Atlas, let's consider the context. Up until now, humanity has only observed two interstellar objects, Oumuamua, discovered in 2017, and 2I Borisov, discovered in 2019. These objects were groundbreaking discoveries, signaling that material from other star systems was passing through our own. 3I Atlas, however, is different. This object has characteristics that challenge what we know about comets and their behavior, making its story even more intriguing. Let's first consider how the 3I Atlas was discovered. A telescope in Rio Haritado, Chile, part of NASA's Asteroid Terrestrial Impact Last Alert System, or ATLAS, picked up a faint speck of light in the constellation Sagittarius, roughly 420 million miles away from Earth. At first, the astronomers thought it might just be another near-Earth object. They didn't anticipate what they were about to uncover. Within a few hours, it became clear that this was no ordinary object. The trajectory of 3I Atlas revealed that it was not in orbit around our sun like a regular comet, but following a hyperbolic path, an open curve that screamed one thing. This object was coming from outside our solar system. Named 3I Atlas, the 3I stands for the third interstellar object ever recorded by scientists. The first was Oumuamua, which passed through our solar system in 2017, and the second was 2I Borisov, observed in 2019. Both of these objects stirred up a lot of excitement in the scientific community, but 3I Atlas is something else entirely. It's much bigger than both of its predecessors, potentially up to 7 miles wide. By comparison, Oumuamua was only about 200 meters, and 2I Borisov was roughly 1 kilometer in diameter. The sheer size of 3I Atlas, along with its unusual behavior, makes it a fascinating subject of study. One of the most unusual things about 3I Atlas is its activity. When comets get close to the sun, they heat up, causing their ices to vaporize and create a bright coma and a tail of gas and dust. This is a standard pattern we've observed in many comets over the years. However, 3I Atlas defies this pattern. When it was observed by NASA's Hubble Space Telescope on July 21, 2025, it revealed a dust trail that was streaming toward the sun rather than away from it. This is highly unusual because based on the physics of solar radiation, the tail of a comet should always be pushed away from the sun. Instead, 3I Atlas had a dust plume, clinging stubbornly to its sun-facing side. It was as if it was flying in the opposite direction of the cosmic winds, which is highly contrary to what we know about comet behavior. Even stranger, early spectroscopic scans, which provide detailed information about the chemical composition of an object, revealed almost nothing. Typically, when a comet gets close to the sun, it releases gases like cyanogen, diatomic carbon, or other volatile chemicals that show up on a spectrogram. These are the fingerprints of a comet's makeup, allowing scientists to understand what materials are present. But in the case of 3I Atlas, its spectrogram was eerily blank. It was as if it was burning without producing the expected chemical signatures. This only added to the intrigue surrounding this object. Only after a while, as it got closer to the sun, did faint traces of cyanogen appear, a sign that the comet might be starting to reveal its secrets. But even then, the appearance of these markers was delayed, as if 3I Atlas was reluctant to give up its mysteries. One possible explanation for the strange behavior of 3I Atlas is that it might be crusted over. Being exposed to cosmic radiation for billions of years in interstellar space could have hardened the surface of the comet, preventing the usual sublimation of ices until it got closer to the sun. This would explain the delayed release of chemicals. Another theory is that its spin axis might be misaligned, meaning only certain parts of the comet are exposed to the sun's heat at different times, causing uneven outgassing. But even this doesn't fully account for the sunward dust plume or the delayed chemistry. Then, the James Webb Space Telescope JWST added another twist. On August 6, 2025, it detected a massive cloud of carbon dioxide surrounding 3I Atlas, stretching over 348,000 kilometers. Interestingly, water vapor, which is usually abundant in comets, was almost entirely absent. This is very unusual because most comets are rich in water. Yet 3I Atlas seems to favor carbon dioxide. This suggests that it might have formed in a region of its parent star system that was colder, possibly near the carbon dioxide ice line, where temperatures are low enough for CO2 to freeze. All of this points to the possibility that 3I Atlas came from a star system vastly different from our own. It could be a relic from an ancient star system, formed in conditions that we've never seen before. But even with all these theories, the reality is that we still don't fully understand what's happening with 3I Atlas. Its size, composition, and unusual behavior continue to challenge our assumptions about the nature of comets and interstellar objects. We've never seen anything quite like it. Now, let's take a deeper look at the discovery and initial observations of 3I Atlas. As mentioned earlier, the object was first detected by a telescope in Rio Haurtado, Chile, on July 1, 2025. This telescope is part of NASA's Asteroid Terrestrial Impact Last Alert System, commonly known as ATLAS. Initially, the astronomers thought they were observing just another routine near-Earth object, one that might have been orbiting the sun or passing through the solar system in a predictable path. However, as the data started coming in, it quickly became clear that this was not an ordinary object. The first thing that set 3I Atlas apart was its trajectory. At first, it seemed to be just another asteroid or comet moving within the usual confines of our solar system. But upon closer inspection, the trajectory showed something far more intriguing. The object was following a hyperbolic path, meaning that it wasn't in a closed orbit around the sun like most objects in our solar system. Instead, 3I Atlas was on a steep, open curve, indicating that it was not bound by the sun's gravity. This revealed a startling fact. 3I Atlas was coming from beyond our solar system. In fact, this object was an interstellar visitor. It had traveled across vast stretches of space from a completely different star system, perhaps many light years away. It wasn't simply passing through our solar system as a transient object, it was making a one-time journey through our cosmic neighborhood. It was moving at an astonishing speed of 130,000 miles per hour, which is incredibly fast, even by cosmic standards. When you consider that most objects in our solar system move much slower, this made the 3I Atlas a fascinating target for study. On making this discovery, scientists immediately set to work tracking the object's trajectory and trying to gather as much data as possible. It was named 3I Atlas, with the 3I signifying it as the third confirmed interstellar object ever detected. The first two, Oumuamua and 2I Borisov, were both groundbreaking discoveries, but 3I Atlas offered an entirely different set of questions to answer. It wasn't just an object passing through quietly, it was an active comet, showing signs of a glowing coma and possibly even a tail of dust and gas, like we would expect from any typical comet. However, this is where things start to get even more unusual. While 3I Atlas displayed signs that suggested it was a comet, its behavior didn't follow the usual patterns observed in other comets. Comets, as we know, are like cosmic snowballs made of ice, dust, and rock. When a comet approaches the sun, the heat causes the ice to sublimate, turning from solid directly into gas, releases dust and gas, forming a bright coma and a tail that always points away from the sun thanks to solar radiation pressure. This predictable behavior has been observed in countless comets over the years. However, 3I Atlas defied this. When NASA's Hubble Space Telescope captured its sharpest image of 3I Atlas on July 21, 2025, from a distance of 277 million miles, it revealed a dust trail that seemed to be heading toward the sun, not away from it. This was completely unexpected. Instead of the usual tail formed by dust and gas being pushed outward, the dust was clinging to the sun-facing side of the object. suggesting a bizarre anomaly in the comet's behavior. To understand why this is so strange, let's consider the physics of comets. Normally, when a comet approaches the sun, solar radiation pushes the dust and gas outward, forming a tail that always points away from the sun. This happens because the heat from the sun causes the comet's volatile materials to evaporate, and as the gas escapes, it pushes the dust outward, forming the tail. However, 3I Atlas seems to be defying this basic principle. The dust is not being pushed away, instead it is staying on the side facing the sun, creating a strange and counterintuitive phenomenon. This has led astronomers to scratch their heads and come up with various hypotheses to explain this behavior. One possible explanation for this strange dust behavior is that 3I Atlas's surface might be crusted over, possibly by billions of years of exposure to cosmic radiation in interstellar space. This outer crust could be shielding the comet's inner ices from the sun, delaying their sublimation until it gets closer to the sun. This would mean that the usual process of dust being blown outward by the solar wind wouldn't apply here until the comet was closer to the sun. However, this doesn't fully account for the sunward direction of the dust, and so it remains an incomplete theory. Another suggestion is that 3I Atlas's spin axis might be misaligned, meaning only specific parts of the comet's surface are exposed to solar heat at different times. This could cause uneven outgassing, which might explain the odd dust trail. However, this theory also fails to explain the direction of the dust stream, leaving scientists to explore other possibilities. Then, things got even more bizarre. As scientists continued to study 3I Atlas, they noticed that it wasn't releasing the expected chemical signals. Normally, when a comet is active, it gives off light at specific wavelengths due to the presence of gases like cyanogen and diatomic carbon. These gases produce characteristic spectral lines when observed through a spectrometer, giving scientists a clue as to the composition of the comet. However, for weeks after its discovery, the spectrogram of 3I Atlas was nearly blank. This was incredibly odd, as active comets are usually quite loud in terms of their chemical signatures. 3I Atlas, on the other hand, was silent, as though it was hiding its secrets. Only later, as the comet neared the sun, did faint traces of cyanogen appear, but they were delayed, much like the dust trail. This raised even more questions and suggested that 3I Atlas was behaving in a way that no other comet had ever behaved before. To add to the mystery, the James Webb Space Telescope, JWST, made a significant observation. On August 6, 2025, the JWST detected a massive cloud of carbon dioxide surrounding the 3I Atlas. This cloud stretched over 348,000 kilometers with a mass loss rate of 70 kilograms per second. This was unusual because most comets are known to be rich in water. However, 3I Atlas seemed to be favoring carbon dioxide, with only trace amounts of water vapor present. This suggests that the comet may have formed in a very different part of its original star system, possibly near the carbon dioxide ice line, where temperatures were low enough for CO2 to freeze into solid ice. This discovery pointed to the possibility that 3I Atlas came from a star system that was vastly different from our own. It was likely formed in a region where the conditions were very different, and the composition of its surface and gas cloud reflected that. The strange combination of carbon dioxide and the absence of water suggests that the physical conditions in the region where it originated were far from the conditions that we're used to seeing in our own solar system. 3I Atlas in many ways has become an enigma, a cosmic visitor from another star system behaving in ways that challenge our understanding of cometary physics. Its dust plume, strange chemistry, and unusual composition all point to the possibility that this object might be a relic from a star system vastly different from our own. Its age, estimated to be between 7 to 11 billion years, makes it an ancient object, potentially older than our own solar system. It's like opening a time capsule from a distant star system, offering us a glimpse into a past that's vastly different from our own. So what exactly is the 3I Atlas? Why is it behaving so strangely, and what does it tell us about the universe? These are questions that scientists are still grappling with. 3I Atlas has forced us to confront the limitations of our current understanding of the cosmos. Each new observation, whether it's the strange dust trail, the unusual chemical markers, or the unexpected carbon dioxide cloud, adds another layer of mystery to this object. For now, 3I Atlas stands as a reminder that the universe is full of surprises, and we're only just beginning to scratch the surface of what's out there. As scientists continued to investigate the mystery of 3I Atlas, more anomalies began to emerge, pushing the boundaries of what we thought we understood about interstellar objects. One of the most perplexing aspects of 3I Atlas is its size. Early estimates from the Vera C. Rubin Observatory, which provided some of the first images of the object, placed the size of 3I Atlas's nucleus at around 7 miles wide. This made it the largest interstellar object ever observed. For context, when we compare this size to other interstellar visitors like Oumuamua and 2I Borisov, it becomes even more intriguing. Oumuamua was only about 200 meters long and 2I Borisov was roughly 1 kilometer in diameter. The sheer size of 3I Atlas stands out among these objects, making it a unique target for study. Later observations from NASA's Hubble Space Telescope refined this size estimate, bringing the maximum size down to 3.5 miles in diameter. But this is still an enormous object compared to others. The fact that such a large object has been spotted in interstellar space, where the odds of encountering an object this size are extremely low, raises significant questions. According to some models, the chances of finding something this big in interstellar space are less than 1 in a million. So the discovery of 3I Atlas was already statistically improbable. But its size, combined with its strange behavior, suggests that it may not be a fluke. Could we be missing an entire population of massive interstellar visitors? If 3I Atlas is indeed part of a larger group of similarly sized objects, it would completely change how we approach the study of interstellar bodies. The Vera C. Rubin Observatory, as part of its Decadal Legacy Survey, is designed to scan vast swaths of space over the next 10 years. It's possible that during this time we might detect up to 50 more objects similar to 3I Atlas. However, for now, 3I Atlas remains an outlier. The discovery of such a massive object this far from Earth is nothing short of extraordinary, and it's making astronomers reconsider how we search for and study interstellar objects. Is it possible that many more such objects exist, but our instruments have simply missed them? If so, 3I Atlas could be part of a much larger phenomenon, one that we're only just beginning to understand. In addition to its size, the trajectory of 3I Atlas is another factor that has captured the attention of scientists. The path it is following through the solar system is nothing short of extraordinary. This object isn't just passing through our solar system in a random fashion, it's threading a cosmic needle. On October 3, 2025, 3I Atlas will pass within just 29 million kilometers of Mars. This is close enough for NASA's Mars Reconnaissance Orbiter to potentially capture high-resolution images of the object. 4 weeks later, on October 30th, 3I Atlas will reach perihelion, its closest point to the Sun, at just 1.4 astronomical units, which is slightly inside Mars's orbit. Then, on November 3rd, it will swing within 0.65 astronomical units of Venus, another rare and remarkable occurrence for a comet. This sequence of events, Mars, Sun, and Venus, all within such a short period of time, is extremely rare and raises many questions about the nature of 3I Atlas's trajectory. Monte Carlo simulations, which run billions of random trajectories to predict the likelihood of an event, show that the odds of an interstellar object passing so close to Mars, Venus, and Jupiter are less than 0.105% or 1 in 20,000. To put this in perspective, imagine throwing a dart at a spinning globe while blindfolded and hitting 3 specific cities in a row. That's the level of precision we're talking about. This highly improbable path has sparked intense debate among astronomers. Some researchers, like Adam Hibbert and Abraham Loeb, have suggested that the precise planetary flybys of 3I Atlas might not be entirely random. In a preprint paper, they cautiously proposed that the object could be a technological object, possibly a probe. They pointed to its alignment with the ecliptic and its potential to use a reverse solar Oberth maneuver at perihelion, a technique spacecraft use to brake using a star's gravity. While most scientists dismiss this as speculative, the idea has gained some traction. The fact that 3I Atlas's trajectory is so unlikely and so precise has led to the consideration of alternative explanations, even if they remain controversial. For now, though, the consensus among the scientific community is that 3I Atlas is a comet, albeit an extremely strange one. It's a natural object that behaves in ways we don't fully understand. Still, the idea that 3I Atlas could be something more, a probe or a piece of alien technology, remains an intriguing, albeit speculative theory. What makes this even more interesting is the fact that its unusual trajectory might actually be a clue about the objects, or if 3I Atlas is indeed part of a larger group of interstellar objects, it could suggest that there is more going on in interstellar space than we've previously realized. The unusual trajectory of 3I Atlas is not the only anomaly scientists are grappling with. Another puzzling aspect of the object is its brightness. When astronomers began analyzing the light curve of 3I Atlas, they noticed something strange. A repeating pattern, like a cosmic heartbeat. This periodicity, detected with over 99.99% statistical confidence, doesn't match the expected spin of a comet nucleus of this size, which should rotate every few hours or days. Instead, the signal pulses on a much tighter schedule, continuing across multiple nights and telescopes including Hubble. This isn't just random noise, it's a real, consistent rhythm that suggests something else is going on. Traditionally, comet brightness changes are attributed to two factors: the comet's rotation and bursts of outgassing from its surface. As the comet rotates, different regions of its surface are exposed to the sun, causing bursts of gas and dust to escape. These bursts typically create fluctuations in brightness. However, 3I Atlas's brightness pattern doesn't align with either of these factors. Some scientists have speculated that the periodicity could be caused by a structural feature on the comet's surface, such as a reflective patch, but this idea has its own set of challenges. The precision of the signal makes it difficult to explain by normal cometary processes. This discovery is a perfect example of how new tools, like quantum AI, are revolutionizing our ability to detect patterns in data. By sifting through massive data sets, quantum AI can pick up on subtleties that human eyes might miss. In this case, it spotted a pattern that is challenging traditional comet science. This is just one example of how modern technology is changing the way we approach space exploration and our understanding of the universe. The mystery of 3I Atlas doesn't end with its trajectory and brightness. There's another anomaly: its acceleration. When scientists plotted the path of 3I Atlas, they noticed a slight but persistent deviation from what gravity alone would predict. This deviation is too large to be explained by the usual cometary outgassing. Normally, when a comet accelerates, it does so because of jets of vaporized ice acting like thrusters. However, 3I Atlas showed this deviation before any signs of outgassing were observed, and the typical chemical markers were either absent or delayed. One theory to explain this deviation is that 3I Atlas's nucleus is unusually thin and reflective, acting like a natural solar sail. As it passes through the solar system, it could be using the sun's radiation pressure to accelerate in ways that aren't typically seen in comets. Alternatively, it could be that the comet contains exotic ices like nitrogen or carbon monoxide that vaporize unpredictably, causing this acceleration. No single model has been able to fully explain the acceleration of 3I Atlas, and this remains one of the object's greatest mysteries. Finally, it's important to address the growing speculation around the idea that 3I Atlas could be an alien spacecraft. This theory has gained traction due to the object's strange behavior, its unusual trajectory, and the debate surrounding its acceleration. However, it's essential to remember that there is currently no definitive evidence to support this idea. While the object's anomalies are certainly intriguing, they can all be explained by natural phenomena, even if they don't fit the patterns we've seen before. The idea of 3I Atlas being a piece of alien technology is an exciting concept, but for now, science requires evidence, and that evidence has yet to materialize. For the time being, 3I Atlas remains an exceptionally strange comet, one that continues to baffle scientists and spark curiosity across the globe. As we continue to explore the extraordinary nature of 3I Atlas, we're faced with even more questions that defy easy answers. One of the most perplexing aspects of this interstellar object is its composition. When we observe the behavior of comets, we expect to see a familiar pattern. As comets approach the sun, the heat causes their ices to sublimate, and they typically produce a bright coma and a tail made of dust and gas. However, 3I Atlas has thrown that expectation into disarray. Its chemistry is unusual, and its dust trail is not behaving in the way we would expect from a typical comet. We've already discussed how 3I Atlas's dust stream appears to be directed toward the sun, defying the normal behavior of a comet's tail. This anomaly was one of the first signs that something was wrong. But as scientists began to investigate further, another significant discovery was made. The chemical makeup of 3I Atlas didn't match any comet we've studied before. Most comets are rich in water, and they produce a variety of gases when they approach the sun, including carbon dioxide, cyanogen, and other volatile compounds. Yet 3I Atlas seemed to be almost devoid of water vapor, with the carbon dioxide content significantly higher than expected. The James Webb Space Telescope, one of the most powerful instruments ever built for studying distant objects in space, provided a crucial piece of evidence that might help explain this unusual composition. On August 6, 2025, the JWST detected a massive cloud of carbon dioxide surrounding the 3I Atlas. This cloud stretched out over 348,000 kilometers from the comet, and the mass loss rate was calculated at 70 kilograms per second. This is significant because carbon dioxide is not typically abundant in comets, which are usually water-rich. The fact that 3I Atlas is releasing such a large amount of carbon dioxide suggests that it may have originated in a very different part of its home star system. Perhaps it formed near the carbon dioxide ice line, a region of its parent star system where temperatures are low enough for CO2 to freeze. This observation challenges our traditional understanding of comet formation. Most comets in our solar system are thought to have originated from the outer regions of our own star system, where water ice is abundant. However, 3I Atlas seems to have originated in a very different environment, one where carbon dioxide was more prevalent than water. This raises intriguing possibilities about the nature of the star system that birthed this object. It could be a region where the conditions for the formation of icy bodies are vastly different from those in our solar system. By studying 3I Atlas, scientists may be able to learn more about the diversity of star systems in our galaxy and the conditions under which comets and other interstellar objects form. Alongside its unusual composition, the size of 3I Atlas is another factor that has intrigued scientists. We've already discussed how it is the largest interstellar object ever observed, with a diameter potentially reaching up to 7 miles. This is significantly larger than both Oumuamua and 2I Borisov, the other two interstellar objects that have been discovered in recent years. The sheer size of 3I Atlas makes it an even more fascinating target for study, as the odds of spotting an object of this magnitude in interstellar space are extremely low. According to some models, the chances of finding such a large object in the vast expanse of interstellar space are less than 1 in a million. So what does the size of 3I Atlas tell us about the nature of interstellar objects? Could it be that objects of this size are much more common than we thought, and we simply haven't detected them yet? The discovery of 3I Atlas challenges our current assumptions about the prevalence of large interstellar objects. If this object is part of a larger population of similar objects, then we may be in the early stages of a revolution in our understanding of the cosmos. Future surveys like the Vera-C Ravine Observatory's Decadal Legacy Survey could provide us with more data on interstellar objects, allowing scientists to further refine their models of how these objects form and behave. Another crucial aspect of 3I Atlas's behavior is its trajectory. As we mentioned earlier, 3I Atlas is passing through our solar system in a way that is incredibly rare. On October 3, 2025, it will pass within just 29 million kilometers of Mars, which is close enough for NASA's Mars Reconnaissance Orbiter to capture high-resolution images of the object. After that, on October 30th, 3I Atlas will reach perihelion, its closest point to the Sun at just 1.4 astronomical units, which is slightly inside Mars's orbit. 4 weeks later, it will swing past Venus, coming within 0.65 astronomical units of the planet. This series of close encounters with Mars, the Sun, and Venus is extraordinary and has led to widespread excitement in the scientific community. However, the odds of an object following such a precise path through our solar system are astronomically low. Monte Carlo simulations, which run billions of random trajectories to calculate the likelihood of specific events, have shown that the odds of an interstellar object passing so close to Mars, Venus, and Jupiter are less than 0.105%, or 1 in 20,000. This is an incredibly rare occurrence, making 3I Atlas's trajectory even more remarkable. The precision of its path raises questions about the object's origin and the forces that might have influenced its motion. Could it be that the 3I Atlas was intentionally directed toward our solar system? This idea has sparked some speculative theories, including the notion that 3I Atlas could be a probe or some sort of technological object. One theory that has gained some attention, albeit in a cautious and speculative manner, is that the 3I Atlas could be a technological object, perhaps a probe from an advanced civilization. Some astronomers have pointed to its precise planetary flybys and the unlikely trajectory as evidence that the object could be intentionally directed. The idea is that the object's unusual path, which aligns with the ecliptic plane of our solar system, could suggest that it is using a reverse solar O-berth maneuver, a technique that spacecraft use to gain speed by passing close to a star. While most scientists dismiss this as speculative, it has raised eyebrows and prompted further investigation into the possibilities of interstellar probes. However, for the time being, the consensus among astronomers is that 3I Atlas is a natural object, a comet, but one that exhibits behavior and characteristics far outside the norm. It's a rare and unusual interstellar visitor, and its strange path through the solar system only adds to the intrigue. But whether it's a comet or something else, one thing is certain: 3I Atlas has changed the way we look at interstellar objects and has opened up new questions about the nature of the universe. As 3I Atlas continues its journey through our solar system, we are left with more questions than answers. The object's strange behavior, its composition, its size, and its trajectory all suggest that it could be a relic from a star system vastly different from our own. It may have originated billions of years ago, and studying it is like opening a time capsule from another star system, one that existed long before our sun was born. Scientists are continuing to monitor 3I Atlas as it moves closer to the sun. As it reaches perihelion, we may see even more dramatic changes in its behavior, potentially revealing more about its chemical makeup and the forces acting upon it. But as it passes through our solar system and heads back into interstellar space, 3I Atlas will remain a mysterious and tantalizing object, offering clues to the diversity of star systems and the many ways in which objects can form and behave in the cosmos. In conclusion, 3I Atlas is more than just a comet. It is a cosmic enigma, a challenge to our understanding of the universe. Its size, composition, trajectory, and behavior are all so strange that they push the limits of what we thought we knew about interstellar objects. As we continue to study 3I Atlas, we are reminded that the universe is full of surprises. Surprises that force us to rethink our assumptions and challenge the very foundations of science. Whether 3I Atlas is a natural oddity or a hint of something even stranger, it is a reminder of how much we still have to learn about the cosmos.